we are going to start about new chapter that is called Force and Laws of Motion. It is a very interesting chapter. What is force? A force is a push or pull upon an object resulting from the object's interaction with another object. Interaction between two objects causing the force upon each other. For example, the trolley moves along the direction we push it. The drawer is pulled. Pushing, pulling or hurling objects change their state of motion. A spring expands on application of force. A spherical rubber ball becomes oblong as we apply force on it. Next is balanced force. Balanced force means two forces are acting on opposite sides of body and that body doesn't change its position. Example, a block pushed from the both sides with equal force. Unbalanced force. Unbalanced force is one that is not opposed by an equal and opposite force to cause a change in the object's position. Example, when blocked with great force on one side. Balanced and unbalanced forces. Two strings X and Y are tied to the two opposite faces of the block as shown. If we apply a force by pulling the string X, the block begins to move to the right. Similarly, if we pull the string Y, the block moves to the left. But if the block is pulled from both the sides with equal forces, the block will not move. Such forces are called balanced forces. Let us consider a situation in which two opposite forces of different magnitudes pull the block. In this case, the block would begin to move in the direction of the greater force. Thus, the two forces are not balanced and the unbalanced force acts in the direction the block moves. This suggests that an unbalanced force acting on an object brings it in motion. Example, what happens when children try to push a box on a rough floor? If they push the box with a small force, the box does not move because of friction acting in a direction opposite to the push. This friction force arises between two surfaces in contact, in this case between the bottom of the box and floor's rough surface. It balances the pushing force and therefore the box does not move. In figure B, the children push the box harder but the box still does not move. This is because the friction force still balances the pushing force. If the children push the box harder still, the pushing force becomes bigger than the friction force. Figure C. There is an unbalanced force, so the box starts moving. What happens when we ride a bicycle? When we stop pedaling, the bicycle begins to slow down. This is again because of the friction forces acting opposite to the direction of motion. It thus appears that an object maintains its motion under the continuous application of an unbalanced force. However, it is quite incorrect. An object moves with a uniform velocity when the forces pushing force and frictional force acting on the object are balanced and there is no net external force on it. If an unbalanced force is applied on the object, there will be a change either in its speed or in the direction of its motion. Thus, to accelerate the motion of an object, an unbalanced force is required. However, if this force is removed completely, the object would continue to move with the velocity it has acquired till then. For example, balanced and unbalanced force. Equal force on both sides, unequal force on both sides. Newton's first law of motion. The first law of motion is stated as an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. In other words, all objects resist a change in their state of motion. In a qualitative way, the tendency of undisturbed objects to stay at rest or keep moving with the same velocity is called inertia. Application of first law of motion. When a bus starts suddenly, the passengers fall backward because of inertia. The passengers tends to remain in the state of rest even if the bus has started moving. Inertia is the property of the body due to which it resists the change in its state of rest or of uniform motion. Mass is the measure of the inertia of a body. Larger the mass, greater is the inertia. Example, when a car stops suddenly, the driver is jerked forward because of inertia. The passenger tend to remain in state of motion even if the bus has stopped moving. Newton's second law of motion. The second law of motion states that the force acting on the body is directly proportional to the mass of the body and acceleration produced in the body in the direction of force is applied. Mathematical formulation of second law of motion. F equal m into a, where F equal force, m equal mass and a equal acceleration. Unit of force. The SI unit of force is Newton. Newton is defined as the force acting on the body of mass 1 kg producing an acceleration of 1 meter bar second square. That is equal kg m by second square or Newton. To calculate force of body having mass 1000 kg and acceleration of 0.5 meter per second square. F equal 1000 into 0.5, that is equal 500 Newton per kg m per s square. Application of second law of motion. Cricket player lower his hands along with the ball to catch it because the acceleration of the ball gets reduces and hence overall smaller force is applied to stop the ball and no injury is caused to the hands of the player. Momentum. The momentum P of an object is defined as the product of its mass m and velocity v. That is P equal m into v. The SI unit of momentum is kilogram meter per second. Hence combined effect of mass and velocity is called momentum. It is a vector quantity. The change of momentum of an object is proportional to the applied and balanced force's direction of force. Formulation of second law of motion. The change in momentum of an object is proportional to the unbalanced force in direction of force. Let the initial momentum be P1 equal mu. Let the final momentum be P2 equal mv. The change in momentum is equal P2 minus P1. That is equal mv minus mu. Rate of change of momentum is m into v minus u by t. Force is equal k into m v minus u by t. Force equal kma, where k is the proportionality constant. Newton's third law of motion. The third law of motion states that when one body exerts a force on another object, the second body exerts an equal and opposite force on the first body. Every action has equal and opposite reaction. Example of third law of motion. How do we walk? When we walk on the ground, our foot pushes the ground backward, and in return the ground pushes our foot forward. Why the cannon recoil? When ball is fired from a cannon, the force sends the ball forward and is equal to the force sending the cannon backward. Hence the cannon is said to be recoil. Conservation of momentum. When two or more bodies act upon each other, their total momentum remains constant when no external force exerts on it is called law of conservation of momentum. Momentum is never created or destroyed. It is also called principle of conservation of momentum. Let two objects of mass ma and mb traveling in the same direction have initial velocities as ua and ub respectively, and their final velocities be va and vb respectively. The, the rate of change of momentum of ball ABF AB equal ma va minus ua by t. The rate of change of momentum of ball BBF BA, that is equal mb vb minus ub by t. According to the third law of motion, every action has equal and opposite reaction. Hence, the force exerted when both objects get collided is FAB equal minus FBA. On solving, we have MAUA plus MBUB, that is equal MAVA plus MBVB, where MAUA plus MBUB is the total momentum before collision and MAVA plus MBVB is the total momentum after collision. The sum of momenta of the two objects before collision is equal to the sum of momenta after the collision, provided there is no external unbalanced force acting on them. This is known as the law of conservation of momentum. Summary. Let us summarize what we have learned. Law of motion. An object will be in the state of rest or in motion until external force acts on it. The mass of the object is a measure of inertia. Force of friction always opposes the motion of objects. Second law of motion, the rate of change of momentum of the object is proportional to the unbalanced force in the direction of force applied. The SI unit of force is kg m per second square. Third law of motion, every action has equal and opposite reaction. The total momentum is always conserved. Okay friends, thank you for watching this video. Bye.